Yeah, now let us go for next example. So for the following matrix, we have to find a non-singular matrix P such that P inverse AP is a diagonal matrix. It means it is sure that this matrix is going to be diagonalizable, which you can easily see. Since it is upper triangular matrix, the eigenvalues are diagonal elements. Remember, the eigenvalues of upper triangular matrix, lower triangular matrix, or the diagonal matrix are the diagonal elements only. And since the eigenvalues are distinct, so therefore it is going to be diagonalizable. Therefore they are saying that we have to find that matrix P such that P inverse AP is the diagonal matrix, and this is the interesting part where we have to find A raised to 1000. Now if you learn the concept of diagonalization, so it is very important that you should be able to solve such type of examples, so therefore we are taking it. So over here I have already done calculations for you. The eigenvalues are 1, 2, algebraic multiplicity is 1. Now to find GM, all the steps are done. So for lambda is equal to 1, okay, you get such type of equation over here. You can easily see that the rank is 1 and the equation is going to be x minus y is equal to 0. Since rank is 1, number of unknowns are 2, so the parameter will be 1. So I have used the parameter for y. You got x to be equal to t only, and this is your eigenspace, and this will be your basis, and this will be your eigenvector. So therefore GM is also 1. And now for lambda is equal to 2, you got this kind of thing. By performing the operation, I got this. Now just note one thing over here, that since the rank is 1, number of parameters obviously should be 1, but this is our equivalent system as x is equal to 0. So if you want, I'll write we have equivalent system. Yeah, so this is our equivalent system, x is equal to 0. So we have to use one parameter, don't use it for x, because we already have the value of x to be 0. So the parameter should be used for y, as y is a free variable. So I have used y is equal to t, t belongs to r, and you got this eigenvector. Okay, so now the question is, what should be our matrix P, since they have asked us. So there are two choices. Either you write the eigenvector of 2 first, or you can write the eigenvector of 1 first. So if you write the eigenvector of 1 first, so whatever diagonal matrix you are going to get, it should have 1 as a diagonal entry first, as a A11 entry. And if you write the eigenvector corresponding to 2 as first, then you should have the A11 entry of the diagonal matrix to be 2. Okay, so this should be clear. I think the first eigenvector was 1 1 and the second one was 0, I guess 1. Am I right? I think so. Yeah, 0 1 and 1 1. So 1 1 is corresponding to eigenvalue 1, I guess. Yeah. So here P is such that P inverse AP is equal to the diagonal matrix, and since that 1 1 is corresponding to 1, so I should have A11 entry as 1, 0 0, and it should be 2, and I will call it as some D matrix. Now since you have to find A raised to 1000, so how to do it? Okay, so what I will do is, from this equation I will find the value of D. So this will imply D is equal to what? So I already have the value of D, so I have to find the value of A actually. So what will be A? I will pre-multiply by P and I will post-multiply by what? P inverse. So that is what I will get. You can see P inverse will be I and P inverse will be I again. I will get A back. So this is equal to, and this P inverse AP is nothing but D. So you will get PD P inverse. Okay, so this is nothing but your value of A. Now you have to find A raised to 1000. So how to do it? Okay, so here what will be A square? So here A square is equal to, I'll write over here to find. Okay, so A square will be PDP inverse multiplied by PDP inverse, because it will be A multiplied by A, isn't it? And PP inverse is simply I, so it will be PD square P inverse. Okay, and if you continue in this way, what will be our A cube? So your A cube is going to be, and A cube will be, which will be A square multiplied by A. We already have the value of A square as PD square P inverse, and this is PD P inverse. So again it will be PD cube P inverse. Okay, and therefore by continuing in this way, what will be my A raised to 1000? My A raised to 1000 will be PD raised to 1000 and P inverse. I hope hereafter you can do the calculations. You already know P. Simply find P inverse, put the values and get the product. That will give you the value of a raised to 1000. Interesting, right? So this is very beautiful application of what? Diagonalization. So we'll stop here. Thank you.